Hi everyone, good morning. Can you see my screen, everyone, online? Can you confirm it? Am I audible? Yeah, in the last session we discussed about SDLC. Yeah, so we have completed four demos, four sessions, right? So far, first session, introduction to DevOps. Second session, introduction to servers, introduction to cloud. Third session, question and answers. Fourth session, SDLC, software development lifecycle, right? Yeah, so before going to cloud infrastructure, before going to start working on cloud. So day after tomorrow, we are going to start AWS. Before going to AWS, first we need to understand servers, networks basics. So yeah, if you understand servers, networks basics, you can easily understand cloud infrastructure, cloud technology. So here terminology is very, very important. Okay. Yeah. So before going to cloud, first we need to understand servers networks. That is why. So today, tomorrow, we are going to work on servers, networks, load balancers, firewalls, right? So subnets, gateways, IP addresses, failovers, clusters. These are all very important. Fine. Yeah. Anyone joined today? Very, still people are joining. Okay. Anyways, let's get started. Yeah, today's agenda here is what is server, types of servers, server client model, best practices, server architecture, what is operating system, types of operating systems, what is network, types of networks, what is IP address, subnet, gateway, router, firewall, failover, and load balancer. So these are all very important for cloud and DevOps engineer. So before going to start working on cloud infrastructure, so first we need to understand this. Okay. Yeah. Today we are going to discuss about what is server, types of servers, server client model, architecture, and operating system, types of operating system. So up to here, this will take nearly 1 hour. Okay. Fine. Let's get started. Yeah. So what is server? What is server? Anyone having idea online server and ఏంటి? What is server? Online guys, real time guys. So anyone having idea about this? What is server? Server is a computer. Server is a computer, right? Yeah, it serves information to other computers called clients. Okay. Yeah. In real time projects, all the data, databases, applications we store in servers only, right? So everyone connect from the databases and like applications and plugins, patches. So everyone connect from the server through network, right? So by using laptop or desktop, we can connect our servers. Okay. Yeah, server is a computer. It serves information to other computers called clients. Either it can be desktop or laptop. So desktops and laptops are client systems. Okay. So in server, centrally we manage the databases, data, applications, right? So from any region, any zone, from anywhere, we can access our applications when we deploy onto server. Okay, see here. This is the definition which I collected here. So a server is a computer that serves information to other computers called clients, can connect to a server through either a local area network or a wide area network such as internet. Through LAN or WAN, through internet we can connect. LAN, local area network, wide area network. So or through internet we can connect our systems. So yeah, LAN WAN wide area network normally, so city to city, so we can configure the wide area networks. Okay, normally we don't configure. So in cloud side, AWS will take care of everything. Okay, yeah. So through by using internet connectivity, we can access from any network. Yeah. Now before going to server types, so server is having high computing power which is a high CPU, high memory, high storage. So normally desktops, laptops, we can configure only one processor and one RAM module or two RAM modules and storage drives, one or two drives. But server side, multiple storage drives, multiple processors, multiple RAM modules we configure, right? Yeah. So TBs, storage size 1 TB to 10 TB, 20 TB. So multiple drives we can insert into the server, right? Even processors also, multiple processors. So in desktop or laptop side, we use the dual core or quad core maximum, right? Here minimum 32 cores, 48 cores like that we use in server side, right? And also, just a minute, one of the student calling. Just a minute. Yeah. Hello.
Hello, Ram. Good morning.
Fine. Yeah, sorry for the disturbance. So one of the student is unable to join the session. So he called me. Fine. Yeah. So servers are having high computing power, high memory, high CPU, right? High storage drives. So most of the databases, data applications we store in the server side. For example, let us take one hospital or colleges, schools, right? So all the student data, all the patient data, all the information they store in the server. They can access from any place, any floor, they can access the data. Centrally, the data will be stored on the server, right? So types of servers, what are the types available? Blade server, a rack server, towered server. So blade server is it is a yeah small unit, small blade, thin servers. So in a single container, we can insert 8 blades or 16 or 32 or 64 like that. So based on the capacity of the container. So these are the physically thin and typically only having CPU, memory only, RAM only. So sometimes storage also inbuilt. Okay. So normally most of the thin servers we use the external storage. We attach external storage, right? Yeah. So here these are the rack servers. These are the traditional servers. So most of the data centers we are using the rack servers only. Most of the companies, most of the data centers. Tower server, which is a very old server. So yeah, currently we are not using this. Okay, yeah. So these two are very popular. So currently most of the enterprise level data centers they are using blade servers. So most of the normal data centers they are using rack servers. Okay, see here. These are the this is the information. So blade server. A blade server is a modular server that allows multiple servers to be hosted in a small area within a small container. We host number of blades as per the requirement, as per the capacity of the rack. Okay. So these servers are physically thin and typically only CPU memory integrated network controllers. So CPU memory. Without storage, how can we store the data? How can we store the operating environment, operating system? So we always use the external storages, right? And sometimes storage drive is also inbuilt. Okay. So blade servers often seen in large data centers like a Google data center, UHG, Verizon, Microsoft data centers. We use the blade servers. They're using blade servers. Okay. So rack servers, a rack server is a model it is a server mounted inside of your rack. So this is a common server every data centers they're using. Okay, so rack is having 48 ports or 32 ports like that racks. So in that we insert servers, we connect power network. So these are the traditional servers. These are the traditional servers. Rack servers are typically general purpose servers that support a broad range of applications and computing, right? Yeah. Next one, tower server. Tower server is a computer that is built in an upright cabinet that stands alone and that designed to function as a server. It is a standalone server. Inside of a tower, only one server we can configure. So we can connect monitor, keyboard, mouse, one CPU only. Okay, this is a bit older server. Currently we are not using in the data centers. Okay, yeah. So currently most of the project teams are using blade servers in cloud environments. Okay, see, client server model, server client. So normally every client connect servers through so network. Either it can be LAN or WAN or Wi-Fi. So when we send request to the server, server give response immediately. So we can access data from the server. We can share the data. We can deploy the data. We can deploy the databases, right? Yeah, this is another model. So we can connect servers through either LAN or WAN or internet. So we can connect. So either it can be desktop or laptop or even tabs, mobile also we can use to connect our servers. Yeah, server architecture. So this server architecture, yeah. So while working on cloud infrastructure, we'll go very deep dive about this. So server architecture is the foundation layout or model of the server based on which a server is created and are deployed. It defines how server is designed. See here, this is the server architecture. While working on AWS, while working on networking part, so we'll go very deep dive here. Okay, now I'll explain few examples here. We'll discuss about server architecture. Yeah. So initial initial stage of implementation, initial phase of implementation, or we can say first phase of implementation. First phase of implementation. Initial phase of implementation or first phase of implementation. This is very important. Yeah. So in 90s and early 2000, in 90s and early 2000, 1990s and early 2000, project teams they used to design the server architecture. Like for example, we have Java and we have Python and we have Tomcat and also we have we can say C. By the time we used to use very old technology C++, for example. Okay, so these are the four applications. These are the four applications. In 1990 and early 2000, project teams used to take for each application they used to take each one server. For one application, one server they used to take. Okay, here we have four applications. So project teams used to take for these four applications four servers. Yeah. So by the time 1990s and early 2000, highest capacity of the server is highest capacity of the storage is 1 GB by the time 1990s and early 2000. So slowly 4.3 launched. Okay. So most of the servers they used to use by the time 1 GB storage. These are all 1 GB servers. Yeah. So four servers, four applications. Here Java. In yeah, first server Java we install, for example. Okay, Java takes nearly, for example, 300 MB, for example. Remaining space will be, so for example we have 1 GB server now. Okay, so I deployed Java, 300 space occupied by Java. So remaining 700 MB space will be wasted, right? 700 MB space will be wasted. Now, so Python occupied, so 350 MB. I'm giving the example only, okay? Not exactly 350 MB, not exactly 300 MB, okay? Yeah, so remaining space will be wasted, which is 650 MB. Yeah, so Tomcat is a application server. It's occupied, for example, 400 MB. So remaining space will be wasted here. Remaining 600 MB space will be wasted. So next one, C++, occupied, for example, 500 MB. Okay, so remaining space, half of this space will be wasted. So 1 GB means 1000 MB, right? Yeah. So 1990s and early 2000 project teams, they used to take for one application, they used to take one server, right? So by the time 1990s and early 2000, server costing, hardware costing, it was too high, too much costing. Yeah, project teams used to spend more budget for the hardware, right? So here utilization is server utilization is less, costing higher. That is why, so this is a failed, this concept, it was failed concept, because project teams used to spend more budget for the hardware, hardware, hardware and network, right? So that is why, so project teams slowly what they did, so in second phase of implementation, yeah, in second phase of implementation, what they did, project teams used to take high-end server, one high-end server. They used to deploy all the packages in a single server, like here Java, Python, and a Tomcat, C++. Okay. Yeah. So here in second phase of implementation after 2000, so they used to configure servers like this. All the applications they host on a single server, and yeah, they give, they used to give access to all the engineers, all the development teams. Okay. So here Java Java user, he can access Java application. Python user, he can access Python application. Yeah. So Tomcat user and C++. So respective engineers, they access their respective applications. Okay. Yeah. So here Java user, along with the Java application, there may be chances to access other application also, right? So Python user, there may be chances to access other application, Tomcat. So Tomcat user, yeah, there may be chances to access other applications also. So because four people are accessing same server, right? So security normally security will be implemented. So but here there may be chances to access other applications also. For example, four people are staying in a single flat, like two-bedroom flat. Okay, so two people are staying in a one bedroom, two people are staying in other bedroom. The four people commonly access kitchen and dining, right? So the same way, so here also Java user may access Python application, Python user may access Tomcat, so C++ user may access Java, right? So like this. So here, what will happen? Very first thing is security issues. Second one is, in case this service crash, what will happen? Entire all the applications will be gone, right? So that is why this is also failed concept. This is also failed concept. Okay. Yeah. So after, yeah, after 2020, slowly, what happened? Virtual servers came into the, yeah, market. Okay. Virtualization. In third phase of implementation, virtualization. What is virtualization, anyone? What is virtualization? What is virtual server, anyone? What is virtual server, anyone? Online guys. What is virtualization? What is virtual server? Yeah. So virtual server is not a physical server. Virtual server is a imaginary server, right? So virtually we can access. Right. So backend. So there, yeah. So if you want to connect any virtual server, if you want to configure any virtual server, so backend we require physical server, right? Physical hardware required. So currently we are using AWS servers, right? In AWS data center, so already AWS team they configure servers, right? So on top of that we are creating the virtual servers. Okay, fine. Now here, this is the base OS. We take one physical server. So this we can call it as base OS. Base OS is a, yeah. So it is a physical server. So this can be any server, right? Physical one. So physical server required high capacity configuration like RAM, 48 GB, CPU, 32 core, and storage 10 TB. Like this, high capacity required here for the physical server. Okay. So on top of this, online guys, everyone following right? Online guys, everyone following right? So any questions up to here? Up to here, any questions, anyone? Everyone following right? Online. Yeah. Yeah. So this is a base OS, which is a physical server. So yeah, this server required high capacity configuration. So on top of this, we deploy software like VMware, hypervisor, or Citrix. So these are all virtual softwares, right? Yeah. So once we deploy this virtual software, on top of this, we create virtual servers. This VMware hypervisor Citrix allows you to create virtual servers. These are all virtual servers. Yeah. So these are all virtual servers. We can deploy different operating systems like Windows 2022 server. Here RHCL, Red Hat Enterprise Linux, Ubuntu we can deploy, and here we can deploy CentOS. So here you can deploy SUSE Linux. As per the projecting requirement, we can deploy different operating environments. Okay. So here 5 into 5, 25 servers we can create. As per the physical server capacity, we can create the virtual servers. Okay. Yeah. So different operating systems we can deploy on the virtual servers. So these virtual servers take the resource from physical server only. This RAM will be shared to the all virtual servers. CPU also will be shared. Storage also normally shared to the, yeah, virtual servers. Fine. So still we are using virtual servers. In project we are using virtual servers. But here also some drawbacks. What are those? So when you want to deploy operating system, we use ISO image. So when we want to deploy operating system, we use ISO image. Even in our laptop or desktop also. So when we want to install Windows on your laptop, so normally what we will do, we prepare one image. That image we can copy into pen drive. So that pen drive we can configure as a portable drive. So by using the pen drive we can boot the system. After that we can deploy the operating system. So the same way, so virtual server also required one ISO image. ISO full form is International Standardization Organization, right? So this ISO image is the master copy, full blowing operating system. Okay, so by using ISO image we can deploy operating system. So clear, right, everyone? Yeah. Now, so this ISO image size is minimum 6 GB to 18 GB. Minimum 6 GB to 18 GB. So on an average, every server, for example, on an average, every server is having 10 GB. 10 GB. 10 into, we have 25 servers. 10 GB into 25. How much? 250 GB. So we need to spend for only operating system. So on top of that, we need to deploy applications, patches, plugins, drivers, right? So that will take more space, fine. And also here, so when you want to restart or reboot your server, okay? So normally in real-time projects, when we want to restart any server, it takes minimum 4 to 8 minutes. When we want to restart any server, it takes 4 to 8 minutes. So 4 to 8 minutes is a high. Normally, client will not accept for this much of time. So this is, we can say, downtime. Okay, so 4 to 8 minutes, client normally they will not accept, because so if you get downtime, if you down the server, so whatever the database are available on the server, whatever applications are running on the servers, okay, that will be down, right? Client business will be impacted. So that is why client, yeah, normally client will not accept for that, right? Yeah, and also when you want to deploy, deployment time and a downtime is high. Deployment time and downtime is high. Okay. So what is deployment time? Anyone? What is deployment? Real time, guys. What is deployment? So when you want to installation, deployment means installation, hosting, right? So when you want to deploy any application, that takes more time. So when you want to down your server, like for example, Flipkart services, okay. So normally Flipkart service is a critical production server. So if you down that server, what will happen? Application will be down, business will be impacted. So that is why client, normally they will not approve for the downtime. Okay, yeah. So if you down the server, it takes 4 to 8 minutes for restarting, because it check the memory, CPU integration, integrated controllers. So all these things will be checked, patches, right? So slowly it will restart. Normally laptop we can restart within few seconds, but server side not like that, takes more time. That is why, so client normally they will not allow for the downtime. So these are all the drawbacks. These are the drawbacks. Okay. So here storage costing is higher here, 6 GB to 18 GB. So on an average 10 GB, it takes 25 servers we have. So 250 GB we need to spend for only operating system. So on top of that we deploy the applications, patches, plugins, right? Yeah, that take more space. And the restart time 4 minutes to 8 minutes. And the deployment time, downtime is higher. These are all drawbacks in virtual servers. Still we are using virtual servers, but these are the drawbacks. Fine. Yeah. So that is why currently project teams are looking for advanced architecture, which is, yeah. So here fourth phase of implementation, which is Docker containers. Docker containers. So which is the fourth phase of implementation. Okay, fourth ways of implementation. Yeah, now let's try to understand Docker architecture. So this is virtual architecture. So same as Docker also similarities are, we can have similarities here. Okay. Now same as virtualization, here we have this is a Docker server, Docker server. So which can be EC2 instance, AWS server, AWS EC2 instance. Okay, instance is a server. This terminology is very important. Instance is a server. EC2 elastic compute cloud, right? Yeah, so this is a server. So on top of this, what we will do, we deploy one package which is, we can say, docker image, docker image. So here we deployed VMware hypervisor Citrix, that is the virtual software. So docker image also virtual software. So cloud side we use the docker image. Okay, so on top of this, we create containers. This docker image allows you to create the containers. These are all containers. Okay, yeah, so we can deploy like Windows 2019 or 2024 also available currently. Yeah, so here we can deploy Ubuntu, RHCL, Linux, Red Hat Enterprise Linux. Okay, CentOS, here Win 2024 also available currently. Okay, so like this, different operating systems, yeah, and different containers we can configure. Okay, now, so when we run the container, so instead of the container, only bin and lib files, only bin and lib file will be, yeah, normally. So when we use the ISO image, what will happen, that is the full blowing operating environment. So but when we run the containers on top of the docker image, only bin and lib, just a minute. Only bin and lib, binary and library, only bin and lib files will be created. Okay, so only bin and lib means minimal configuration, minimal files. Okay, so when you want to deploy war files or jar files or ER files, normally developer develop the code in their local Git, local workspace. So in the last session we discussed the SDLC. So developer develop the code in their local workspace, local Git. Once development is completed, they push the code to GitHub remote repository. So from GitHub, Jenkins take the code. So once Jenkins take the code, so it will convert into artifact by using the Maven. So once it is generate the war file or jar file or ER file, that will be pushed to the application servers to deploy the war file and application server. So the same way, on top of the in container also we deploy the war files, jar files, ER files. Okay, yeah. So to deploy the war file or jar file or ER file, we required only bin and lib only. We required bin and lib is enough. So we don't require any ISO image. So when we configure ISO image, when we deploy operating system by using ISO image, so it is a full blowing operating system. In that paintbrush, media player, right, and notepad, so everything is available. But whereas containers only binary library. Okay, so here operating system environment is 200 MB only. So here ISO image size is 6 to 18 GB, but whereas container side only 200 MB. It is minimal configuration, minimal size. Okay, so lightweight, very lightweight, standalone, right? Yeah, and also, yeah, along with the applications and operating environment, everything. So maximum 650 MB only container side, right? So when you restart your container, it takes 15 seconds only, very faster. When we restart the container, it takes 15 seconds only. So very faster. So auto, yeah, that is why currently every digital application they are using Docker containers. Like for example, we are online shopping. So when we book any groceries or when we book any products online, so backend they are using containers. That is why. So when we place the order, so immediately that is processing, right? So because of backend they have Docker and Kubernetes, fine. And also deployment time and downtime is deployment time and downtime is less. Deployment time and downtime is very less because when you deploy any application on a container, it takes a few seconds only. So when you restart your container, within 15 seconds the container will be restarted. Even the developers who are working on the containers, so they will not understand either it is restarted or not, very faster. Okay, so these are all advantages. Moreover, the licensing costing is very less. Cost effective licensing is very yeah. So normally Docker license I'm talking about, okay, very less costing. But whereas here operating system license cost here, right? Windows license, Red Hat Linux license, right? So Red Hat Linux and Ubuntu, CentOS, these are all for community edition, it is free. Enterprise edition costing licensing. But whereas Docker licensing is one third cost only compared with the virtualization or any other license, only yeah one fourth cost, not one third, one fourth cost. That is why so client always look for the cost saving and time saving. That is why every project team they are migrating their applications to Docker containers. Okay, so currently most of the project teams they are using Docker containers. That is why yeah. So Docker Kubernetes is very popular now. So if you are good in Docker or Kubernetes, you can easily crack your interview. You can easily pop up in the projects. Fine. Yeah. So Docker launched in 2013. 2013. Docker launched in 2013. So immediately after 1 year, Kubernetes launched. Kubernetes 2014. So why they launched Kubernetes immediately? So Docker vendor is Docker Inc. Docker vendor is Docker Inc. Kubernetes vendor is Google. Kubernetes is the Google product. Okay. So after 1 year, immediately Kubernetes launched because in Docker also we have clustering issues. Clustering issues. That is why after 1 year, Kubernetes launched. So Kubernetes is advanced to Docker. If you understand Docker, you can easily understand Kubernetes. Okay. So Docker Kubernetes is very hot in the market currently. Okay, so if you are good in Docker or Kubernetes, along with that one cloud platform, you can easily crack your interview. You can easily pop up in the projects. Fine. And also here, Docker supports 95,000 containers. These are the entry questions. Kubernetes supports 3 lakh containers. Okay, so these are all yeah I give you a few more points while working on Kubernetes and Docker. So Docker launched in 2013. Docker Inc is the Docker vendor. Kubernetes launched in 2014. So Google is the vendor. So Docker supports 95,000 containers. Kubernetes supports 3 lakh containers. These 3 points are very important entry questions. What is the difference between Docker and Kubernetes? And also creating cluster is very challenging in Docker. creating cluster is very challenging in the Docker. So creating cluster in Kubernetes is very simple. By using single command, we can configure the cluster. These are all differences, important differences, right? Yeah. So that is why every organization they are migrating their applications to Docker containers. So Kubernetes is having dependency on Docker. So before deploying Kubernetes, first we need to deploy Docker. Without Docker, Kubernetes will not work. Okay. So these are all, yeah. So very important advantages of Docker and Kubernetes. Clear, right, everyone? Any questions up there, anyone? Anyone having any questions so far? Anyone having any questions so far? Online?
Yeah, sir. If one
Yeah.
container means, is it one server or?
Container is not a server. So container in general, container is a just like box. It is just like box.
Okay.
You can move anywhere, you can use anywhere. It is very lightweight, standalone.
Okay, but what we will keep in that? Like a server or an operating system?
Applications, operating system. So it's the same,
Okay.
yeah, same like a server, but it is not a server.
Okay.
There is a difference, huge difference.
And this Docker supports 95K containers means in one server, or how does it be
Exactly,
calculated?
exactly. Yes, one server. Yes,
In one server, 95K containers.
yes, correct. Okay,
Okay. Okay.
fine.
Sir, what is
Any-
clusters?
Right, cluster is very important here. Okay, so clusters. Yeah. So what is cluster? So this is also very important interview question. So most of the interviews I have got this question. So cluster is a group of servers. Group of servers are group of devices. Okay. And advantage of cluster, benefits. Advantage of cluster. First one is load balancing, and also load balancing, and also second one is fault tolerance. Load balancing and fault tolerance. Okay. Yeah. So cluster is a group of servers. Why we require group of servers? For example, in our project, 10 members are working on the, yeah. So 10 members are there. DevOps engineer, for example, DevOps engineers. They're handling, everyone handling 30 requests per day. 10 into 30, 300 requests per day. Everyone, yeah, 10 members they are getting. Okay. So in that 10 members, 5 members went on leave. What will happen? Load will be balanced. The load will be balanced to others, right? And also in that 5 members, 2 members left from the organization. What will happen? Project will not be stopped. Project will not be stopped, right? So cluster is a group of servers. Advantage of cluster is load balancing, fault tolerance. So in case the load is coming in, the load will be balanced to all the servers. In case server is crash, one server is crash, nothing will be happen. Other servers will take care of the resources. So this is very important entry question. Group of servers or group of devices. Clustering, right? Advantage of cluster is load balancing, fault tolerance. Clear, right,
Ram,
everyone?
yes.
Yeah. Yeah. Go ahead, please.
This Docker server is created on top of this AWS EC2
Exactly.
instance, right?
Normally we
So
use the clouds.
it will use the
Cloud.
capacity of this EC2 instance, or
Yes. We take high capacity here. This Docker server also will take higher capacity
So
as
all
per
these
the project.
containers will use the capacity of this Docker server, right? Means the EC2
Exactly,
instance.
exactly. Yes. As per the project requirement, we can create the this Docker server, EC2 instance, cloud server. So creating EC2 instance is 1 minute job. Within 1 minute, we can create the n number of EC2 instances in cloud.
So container will be this container will be the means the small box, right, which are created out of this
Exactly.
EC2
Yes.
instance. Okay, okay,
Correct.
okay.
Fine. So this Docker concepts and virtualization concepts also we'll discuss while working on. Yeah. So before deploying configuring Docker, so first we'll see this virtualization in our Docker sessions. Okay. So Docker will go very deep dive. Nearly Docker takes 8 to 9 days. So not only installation configuration, not only basics, we'll go very deep dive. So because currently Docker is very hot in the market, right? So Docker Kubernetes, you need to focus on, even Jenkins also. Okay, we have nearly 14 tools are there in our course. So if you learn all the tools, you can fit with any project. Okay, project to project, different tools they use. Okay, yeah. Now let us go back. Next one. So any more questions here before going to next slide? Any more questions here? Anyone? It's clear, right, everyone? Yeah. Next one is operating system, right? So what is operating system? Anyone? What is operating system? In our laptop, we are using Windows. Windows is the operating system. So in Linux, some of the servers we are using Linux operating system, Solaris operating system, Mac OS. So what is operating system? So operating system is before discussing about that, for example, computer hardware always understand the binary language. What is binary? Zeros and ones. 000 001 100 111. So like that binary language understand by computer hardware, but human will not understand that binary language, right? So normal users, they cannot understand the binary language. That is why we require one translator, which is operating system. So operating system is an interface between user and the computer hardware, right? So see here, this is the definition. Operating system is an interface between user and the computer hardware. The hardware of the computer cannot understand the human readable language as it works on binaries, that is zeros and ones. In such case, we need an interface which can translate human language to hardware and vice versa for effective communication, right? See, between hardware and end user, we have operating system. Next one, types of operating systems. What are the types available? Single user, single tasking operating system. So in this type of operating system, only one user can log into the system. You can perform only one task at a time, right? So which is, for example, MS-DOS. So Microsoft Data Operating System, which is very old operating system. So in this type of operating system, only one user can log into the system. You can perform only one task at a time, right? So second one is single user multitasking operating system. So in this type of operating system, only one user can log into the system. You can perform multiple tasks at a time. For example, Windows. In Windows, while browsing internet, what we will do? We run background audios. While working on any tasks, we run background audios. So in our previous organization, so people, they used to work in night shifts. They used to work in tickets, but they run background audios, something. Okay, multiple tasks we can run at a time, but single user, right? Yeah, that is a single user multitasking operating system. So third one is multi-user multitasking operating system, right? So multiple users can connect to the servers. They can operate multiple tasks at a time, which is Unix and Linux. So currently, most of the data centers they're using Linux servers. So why Linux? What is the importance here? Security. Compare with Windows, so Linux is more secure, right? So when we deploy any databases, critical applications, digital applications, so Linux is having security layers. So any virus is released, so directly attack to the first Windows. Linux is very safe. That is why every project team they're using Linux servers to protect the applications, databases, right? So server side always use the Linux, but desktop, laptop side always use the Windows. Fine. Clear, right? So in Linux we have different flavors available. Linux we have different flavors. Ubuntu, RHCL, CentOS, Amazon Linux, right? Windows also we have different versions. Fine. Yeah. So these are the very important concepts so far. So tomorrow we are going to work on networking part. Yeah. So up to here we covered today. So tomorrow we are going to start networking. So networking terminals are very very important. Networking terminals. So tomorrow we are going to cover clusters also, clustering concept also. Okay. So any questions, anyone? Anyone newly joined today, first session? Can you share your WhatsApp number and email address in the chat? So my mobile number already gave you, right? 96422 Can you share your mobile number and what's email address in the chat so that we'll provide you previous recordings. WhatsApp group already created, so people already added into WhatsApp group. So if you are interested, you can make the fee and you can add into WhatsApp group as soon as possible. So very soon the link will be changed. The meeting link will be changed. Okay, so you can add into WhatsApp group so that we'll share all the information in the WhatsApp group only. Fine. So if you have any more questions, if you want to talk to me, so if you have any confusions, you can reach out to this number. So my mobile number is 96422 Fine. So tomorrow we are going to work on networking concepts. Okay. So after that we'll start AWS day after tomorrow. So day after tomorrow onwards, everyone required laptop for practice. Okay. So daily basis everyone practice. Fine.
So Ram,
So
means how much?
yeah,
So daily,
yeah,
how much time is required, right, to practice and to make
yeah.
this
So
perfect?
daily 1 hour live class you need to attend. After that, minimum 1.5 hour you need to practice. So that within 3 months you can crack your entry within the 3 months. So you can easily cope up in the projects also. So real-time tasks, real-time challenges, real-time activities, day-to-day tickets. So FAQs, these are all will be covered in our course. Interview preparation, resume preparation, certification support. Fine. So can wind up here. So tomorrow maybe link will be changed. So everyone, the people who are not registered so far, you can register today itself. Okay, you can add into WhatsApp group. Fine. Thank you all.